This question is about silver nitrate. Define standard enthalpy of formation. So this is just a learn answer. So we're looking for the enthalpy change, or if you want, the heat energy change at constant pressure, because that's the definition of enthalpy change, when 1 mole of a substance, so of a substance, maybe a compound, is formed, so that's the formation part, from, what's it formed from? Its elements, all substances in their standard states. Silver nitrate 5 is formed when silver nitrate 3 undergoes thermal decomposition, and they've given us an equation. They've given us the standard enthalpy of formation of NO3, the standard enthalpy of formation of NO, and they've asked us to calculate the standard enthalpy of formation of AgNO2. Not given us silver, but that's because silver is an element already, so by definition its enthalpy of formation will be 0 because it's already an element in its standard state. I'm going to draw a Hess cycle. There is an equation that you can use, but I think it's important to understand where that equation comes from, and it comes from the Hess cycle. So this thermal decomposition is plus 56.2. Formed from the elements, so we've got silver, which is a solid. We've got nitrogen, but we've got 2 silvers. We've got 1 nitrogen gas, and we'll have 2 O2 gases. That's the elements from which we can form this, and that is the enthalpy of formation, the one we're trying to find out, X, from its elements. So Ag to Ag is 0. So this arrow would be nothing. Ag, one of the Ags, an N, and 3 of the oxygens go up here, minus 1, 2, 3. And then one of the N's and one of the O's goes up here, plus 90.4. So in total, if we add up, in fact, we ought to just add that this is going to be 2x because we're forming 2 of the AgNO2s. If we add up the right-hand side, we've got 123 minus 123, and 90.4. So in total, this side, sort of the total of this arrow is minus 32.6. So that's like a total. So let's just put that in brackets so we don't get confused. So using Hess's law, the arrow we want to find, it starts here and ends here. So according to Hess's law, we could go this other way. And so we're saying that 2x is equal to, so in total our arrows on the right hand side pointing up were minus 32.6. And then we want to go against the next vector, so minus the plus 56.2. So in total, minus 88.8. So one of those is minus 44.4. Now, if you use the equation, which will work here because everything's the same type of data, the equation way of doing it, if you can remember it, is that the enthalpy change is the sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation of the reactants. And so you could have said 56.2 equals the sum of minus 123 plus 90.4 minus the sum of the reactants, so minus 2x, and rearrange to get the same equation that I had and get the same answer. Suggest why the enthalpy change for the thermal decomposition of solid silver nitrate 3 is difficult to determine experimentally. Well, it was an endothermic change, so it must be heated to cause decomposition. So how are you going to measure the temperature change? So you cannot measure the temperature change, because remember, to do Q equals mc delta T, you need to be able to measure the temperature change. If you're heating it with a Bunsen burner, how do you know how much the chemicals are changing temperature? Because you'll be measuring the temperature of the Bunsen burner. Solid silver 5 nitrate solution reacts with solid sodium chloride. A student does an experiment to determine the enthalpy change for this reaction. So they've measured out 50 centimetres cubed of, using a measuring cylinder, 50 centimetres cubed of 0.1 mole per decimetre cubed silver nitrate. And they've put it in a glass beaker. They've weighed 2 grams of sodium chloride and tipped it in and reweighed the weighing boat. They've added a lid to the beaker that will reduce the heat loss. They've stirred the mixture while recording the temperature with a thermometer. Identify 3 aspects of this method which could cause inaccurate results. Well, the first thing is that they're using a glass beaker instead of a polystyrene cup. When you do these enthalpy change experiments that are not about fuels, then you would want to use a polystyrene cup to minimise heat loss. They're much better insulators. Okay. So when did they record the temperature before they added the solid? How will they know how much the temperature changed when they added the solid if they didn't record the temperature at the start? So how would we improve it? We would record the temperature of the silver nitrate before adding the sodium chloride. And then what's our next improvement? So we need to have a think about what else is going on here. So they used a clean dry measuring cylinder. They've poured it into a glass beaker. They haven't explained how they're going to record the temperature. So they've recorded the maximum temperature reached. So really a better way to do this would be to record the temperature regularly and plot a graph. So the method does not take account of heat loss. So measure temperature every minute and plot a graph and extrapolate to find delta T at time of addition. So you could think about if you had it, we could draw this graph and find the temperature change. That would account for some of the heat loss. I mean, there's another couple of things here we don't really know, but the concentration of silver nitrate is quite low. So we might not get a very big temperature change here, and that would lead to bigger errors. So we could use a higher concentration. There's also a temperature change that occurs when you dissolve any solid into a solution, and we haven't taken account of that. But those are things that maybe you would not be aware of at this stage. I think these three would be the best 3 errors to say in terms of your understanding of the practical.